imagine a world where everyone is healthy and there is no untreatable infection. Unfortunately, every day this gets further and further away from reality. Antibiotic resistance is one of the major causes of infectious illnesses in Thailand, and the treatment for basic infection is more difficult and getting more risky. Good morning, my name is Napasorn Thongphailin. I'm from Suraviva School, Thailand. Today I'm proudly presenting my research with a comparison of the percentages of drug-resistant bacteria colonized in the gastrointestinal tract of commercial and free-range chicken. Ladies and gentlemen, the fact that chicken plays a crucial role in food industry is not exaggerated. With an export volume of 910,000 metric tons. Furthermore, demand for protein meat is expected to continue increasing due to the population growth and rising individual consumption. Have you ever wondered how could farmers can produce this massive amount of livestock to supply this trend? So right now, Fang is talking to the farmer and the academic. Hello, Fang. Thank you, Ms. Napasorn. Let's talk about farming. Their approach to breed livestock. Most chicken produced are raised in commercial closed-system farms to increase productivity. Antibiotics have been directly given to the livestock and in some formula of their feed. Next, I will talk with the academic. While smaller farms are usually free-range bred chicken, which means chickens are set free and are able to find food in their surroundings. Nevertheless, instant feed containing antibiotics are still given to the swine. Lastly, many households in the rural area raise chicken with only organic residues from their crops. The bacteria are excellent survivors, as they can become resistant to antibiotics easily and rapidly. How long do you think it will take for the bacteria to become resistant to antibiotic if it is 3,000 times more concentrated than the initial one? 11 years or 11 months. Actually, this experiment from Harvard Medical School presents the bacteria can mutate within only 11 days to become resistant. They decrease antibiotics uptake after the target site, inactivate or modify enzymes that can bind with the antibiotics. Hence, the same dose of the same medication is no longer effective in curing illness caused by the resistant bacteria. The scariest thing about this is that resistant gene can be transferred to other bacteria through a process called horizontal gene transfer. The four common mechanisms are conjugation, transformation, transduction, and using gene transfer agents such as virus. With that being said, if microorganisms in the chicken GI tract such as Escherichia coli and Enterococcus come to be resistant, their resistant genes are possible to be passed on to pathogens in the environment and to other livestock. Thus, if the vulnerable groups such as infants and elderly people become infected, their lives could be at risk. There are three antibiotics being illustrated here. The first one is imipenem, the second is ceftazidime, and the last one is vancomycin. This is because in recent years, vancomycin-resistant enterococci and ESB are producing Enterobacteria S are the common drug-resistant crisis. Generally speaking, if the bacteria is resistant to this drug, they will more likely to be able to resist other antibiotics as well. This study aimed to investigate the prevalence of colonization of imipenem and ceftazidime resistant Escherichia coli as well as vancomycin resistant Enterococcus, and to compare the prevalence of antibiotic resistance in commercial chicken using antibiotic mixed feed and free-range chicken using organic feed. Perhaps if antibiotics have been used at low concentration for a long period of time, there will be a higher percentage of antibiotic resistance among bacteria colonized from commercial farms than the free-range one. For the methodology, we use screening method. divided into 4 parts as follows. Part 1. Sample collection. Part 2. Bacterial isolation and identification. Part 3. Antimicrobial susceptibility test. And the last one, data analysis. Here is the identification of Escherichia coli and Enterococcus from the biochemical test. We use citrate test, urease test, TSI test, lysine test, motility test, and indole test. For the Escherichia coli, use catalase test, bioscaline test, and 6.5% sodium chloride test for Enterococcus. The percentage of Escherichia coli colonization from commercial farms were the highest, followed by those from free-range backyard and free-range farm respectively. At the same time, the percentage of Enterococcus colonization from free-range backyard were the highest, followed by those from free-range farm and commercial farm respectively. With the CLSI published guideline, the antimicrobial susceptibility test conducted using the Kirby Biotics diffusion technique result can be interpreted. There are charts for specific organisms for each drug. There are interpretation charts that indicate on the record sheet whether the zone site is susceptible, intermediate, or resistant. After analysis, we can see that there was no resistance among bacteria colonized from the free-range backyard, while there are some occurrence of resistance among those from free-range farm. The resistance percentage was the highest among isolation from commercial farm. It is reasonable that the more we use antibiotic, the less likely we will find the colonization of the bacteria, right? Surprisingly, there were the highest percentage of Escherichia coli colonies present from commercial farms, which antibiotics have been used the most. The rationale behind this could be that these microorganisms are antibiotic-resistant bacteria, leading to our later investigation, the antimicrobial susceptibility test. According to the AST, the results were just as we expect. There was significantly higher percentage of antibiotic-resistant bacteria colonized from chicken with antibiotic use than those without antibiotic use. If you couldn't imagine this violence, I want you to listen to this news. For 16 years in Norway, researchers have successfully tracked the spread of antibiotic-resistant genes and have shown that these genes are being transferred between Escherichia coli strains. From such research, they have said that Escherichia coli will not harm if it could be in our intestine, but if such bacteria enter the bloodstream, it is immediately fatal. I could end off the report, and thank you for watching, and then I will return to Mr. Pason. Thank you, Fang. In conclusion, our prolonged use of antibiotics can worsen the antibiotic resistance crisis. As customers, we have the power to stop the occurrence by choosing organic products. Because the higher demand from the market, the more likely farmers will switch their farming methods to the organic one. The occurrences of antibiotics are still present in an alarming ratio. Action should be taken for the legacy of antibiotics treatment. After all, I would like to acknowledge the support of Surariwa School, Suratnari University of Technology and the Science Program, and our advisors and co-advisors. It is such an honor to be here. Thank you for your attention.